This section is on angles of elevation and depression and doing word problems with basic right triangle trigonometry, SOHCAHTOA. So an angle of elevation is the angle formed by looking straight across and up to something. So across and up. So here's an angle of elevation. Angle of depression is the angle formed from looking straight across again but down. So here's the angle of depression. The angle of depression is often confused with this angle in here, and that is not the case. That's not an angle of depression. Now, one thing to note is that horizontal is parallel to horizontal, and so the angle of depression and angle of elevation are congruent because alternate interior angles are congruent if lines are parallel. So we'll take a look at a couple sample problems and then do some word problems as well. So here we have an angle of depression of 26 degrees. This height's 25 feet. Find this horizontal distance. So we know that if this is 26 degrees, that means this angle here must be 26 degrees. Compared to this angle, this is an opposite side, this is an adjacent. So we use tan 26 is 25 over x. Doing a little algebra, I can switch these two, and I get x is 25 over tan 26, which comes out to approximately 51.3 feet. And I include the units because I began the problem with units. Over here, we have an angle of depression of 27 degrees. So again, that's congruent to the angle of elevation over here. And so opposite over hypotenuse is sine. So sine of 27 degrees is x over 580. Multiply 580 to both sides, and you get approximately 263.3 yards. Okay, the Americans with Disabilities Act states that wheelchair ramps can have a slope no greater than a 1/12. Find the angle of elevation of a ramp with this slope, and your answer to the nearest 10th. Now, good thing about these problems is you know you got a right triangle to deal with. So first, draw a right triangle. That'll get you going. So now, if the slope is 1/12, slope is rise over run. So I'm going to make the rise 1. I'll make the run 12. And I'm trying to find this angle because that's the angle of elevation. Well, compared to this angle, we have an opposite and adjacent. So that's going to be tangent. So tan theta is 1/12. We don't know the angle. We want to get the angle. So we use an inverse trig function. So theta is the inverse tan of 1/12, which comes out to about 4.76 degrees. So again, these are always going to be right triangles. So that's how we can start setting things up. So in this case, a little trickier. Two office buildings are 51 meters apart. The height of the taller building is 207. The angle of elevation from the top of the taller building to the top of the shorter is 15 degrees. Find the height of the shorter building. Okay, so the idea is that the height of the shorter one, we're going to call that h. Okay, so that means this is h over here as well. We don't know what this is, so that's going to be x. But we do know that if you take this h and you add x, you're going to get 207. Now, also, this angle is 51 degrees, which means that this angle down in, or excuse me, 15 degrees, that angle is also 15 degrees because they're alternate interior. Now, compared to that angle, x is an opposite, 51 is an adjacent, so we can use tangent. So tan of 15, x over 51, multiply by 51, and we get x is 13.67. So now we know the 207 and we know x. And remember that h plus x is 207. And since I know what x is now, I know the difference between the height of the two buildings. I can plug it in and subtract it. The lower building then is 193.33 meters. And finally, we have a blimp providing aerial television views of a football game. The blimp is up here. Okay, here we have the blimp. And here's the football game we're looking down to. The angle of depression is 7 degrees, which means that we're going to have 7 degrees here because they're alternate interior. The blimp's altitude is 400 meters. What's the line of sight distance? Now, line of sight distance is not this horizontal distance. Line of sight distance is straight along here, so we need this side. So compared to this angle, we have an opposite. So we're going to use sine. So sine is 7 degrees. We'll call this L for line of sight, I guess. Over L. I do a little algebra to switch these two. L is 400 over sine 7, which comes to 3282.2 meters.